A lot of people in data engineering are asking the same question right now. Will AI replace data engineers? And honestly, I understand why the people are worried. AI can write SQL queries, AI can generate PySpark code, AI can explain errors, AI can even create documentation and pipeline logic. So the question is valid, but my honest answer is this. AI may not replace every data engineer, but it will definitely change what data engineers are expected to do. So in this video, I will explain what AI can replace, what AI cannot replace, who is actually at risk, and what should you learn in 2026 to stay relevant with the current market. Hello everyone, welcome to Big Data Fact. I am Ranit and I have over 4 plus years of experience working as a data engineer. If this is your first time visiting this channel, don't forget to subscribe for more content on big data and real world insights. Now let's talk honestly. First, let me give you the direct answer. No, AI is not going to replace every data engineer, but AI will definitely replace some repetitive tasks. It will replace some slow ways of working, and it may replace people who only know how to copy syntax without understanding how data systems actually work. That is the important difference. Because data engineering is not just writing code. Data engineering is about understanding where data comes from, how it changes, how it should be cleaned, how it should be modeled, how it should be trusted, and finally, how it becomes useful for business. So the goal is not to fight with AI. The goal is to become the kind of data engineer who knows how to use AI but still understands data flow, architecture, quality, and business logic. This is where your real value will be. Now let's first be honest about what AI is really good at. AI is very useful for writing first drafts of SQL queries. For example, if you need a query with joins, aggregations, CTEs, or window functions, AI can give you a starting point very quickly. AI is also very useful for PySpark code. It can help you write transformations, read and write files, create basic data frames, and generate sample code faster. It can also explain errors. Sometimes when a Spark job fails or a SQL query gives an error, AI can help you understand what that error means. AI can also help with documentation like README files, project explanations, table descriptions, comments in code. All of these can be created faster with AI. It can also suggest test cases. For example, it can help you think about null checks, duplicate checks, schema checks, and row count validations. So pretending AI is not useful is not realistic. AI is useful. It can save time, it can speed up learning, it can reduce blank page thinking. But here is the important point. AI is very good at helping you start faster. But starting faster is not same as the owning a full pipeline. Now let's talk about what AI cannot replace. AI can write a query, but AI may not know whether that query gives the correct business answer. And that is where real data engineering starts. For example, AI can write a join, but will it understand that one table is at order level and another table is at item level? Will it know that the join may have duplicate rows and infinite revenue? Maybe sometimes, but can you trust it blindly? No. AI can generate a pipeline, but will it understand why bronze should preserve raw data, why silver should clean and validate it, and why gold should be business ready? Only if you guide it properly. AI can suggest a transformation, but will it understand the actual meaning of a business rule? For example, what exactly counts as an active user? What counts as a successful transaction? Should cancelled orders be included or excluded? Should late arriving events update yesterday's metrics? These decisions are not just coding decisions. They are business and system decisions. AI also cannot fully replace ownership. When data breaks in production, someone still has to investigate. Someone has to check logs. Someone has to compare the source data and raw data. Someone has to talk to the stakeholders. Someone has to explain why the dashboard number changed. That person is still the data engineer. So remember this, in data engineering, the hard part is not only writing the code. The hard part is understanding the data, the system, and the consequences of wrong output. Now let's talk about who is actually at risk. I don't think data engineers as a whole are at risk, but some habits are definitely at risk. If someone only memorizes syntax, that is risky. If someone only depends on one tool and never understands the underlying concepts of the tool, that is risky. If someone builds data pipeline but never checks the data quality, that is risky. If someone does not understand table grains, joins, duplicates, partitions, schema changes, and business logic, that is risky. Because AI can produce code. But if you don't understand whether that code is correct, then you are depending on AI blindly, and that is dangerous. So here is the simple truth. If your only skill is writing basic code, AI can compete with you. But if you understand data flow, architecture, quality, and business impact, AI can become your assistant. That is the shift. Don't become only a tool operator, become a system thinker. So, what should data engineers actually learn in 2026? Let me keep this very practical. First, learn SQL deeply. SQL is still the foundation, not just basic search statements. You should be strong with joins, window functions, CTEs, aggregations, subqueries, case statements, and query logic. Second, learn Python and PySpark properly. Don't just remember syntax, understand data frames, transformations, joins, partitions, shuffles, file formats, and why Spark jobs become slow. Third, learn pipeline design. This is where many beginners miss this point. A good project is not just code. A good project has structure. Raw data should be separated from clean data. Clean data should be separated from business metrics. That's why concepts like bronze, silver, and gold matters. Fourth, learn data quality. In the AI era, trust becomes even more important. Someone still has to check whether the data is correct. So learn null checks, duplicate checks, schema validation, row count checks, and reconciliation. Fifth, learn cloud and platform basics. You don't need to know every cloud service in the world, but you should understand storage, compute, orchestration, security, and how data moves through a platform. And sixth, learn how to use AI in your workflow. Use AI to create first drafts, use it to debug faster, use it to document better, use it to generate test ideas, use it to improve your productivity. But always review your output. Don't use AI as a replacement of thinking. Use AI as a faster way to execute your thinking. This is the key. Now, if you are a beginner, I don't want you to panic, but I also don't want you to learn randomly. Here is a simple path. Start with SQL, then learn Python basics, then learn Spark, and after that, build 2 to 3 real projects where data moves from raw to clean to business output. Then learn cloud basics, then learn orchestration and data quality. And throughout this journey, use AI to speed up your learning. Ask AI to explain errors. Ask it to review your SQL. Ask it to suggest edge cases. Ask it to improve your README. But don't just copy and paste. Understand what it gives to you. Because the goal is not to become someone who only prompts AI. The goal is to become someone who understands the problem well enough to guide the AI properly. So will AI replace data engineers? My answer is AI will replace some tasks. AI will replace some repetitive workflows. AI will replace people who refuse to adapt. But AI will not remove the need for people who understands data systems, business logic, data quality, and reliable pipelines. The future data engineer is not the someone who write the code properly. The future data engineer is someone who can design systems, validate data, explain trade-offs, and use AI to work faster. So don't be scared of AI, but also don't ignore it. Learn the fundamentals, build real projects, use AI as an assistant, and become better at thinking through data systems. This is how you stay relevant. So this is all for today. In the next video, I can show you how data engineers use AI in the real workflows. Comment AI if that is the next video you want. If this helped, drop a like and subscribe to Big Data Factory. I will see you in the next video. Till then, keep learning and keep building. Bye bye.